Okay, so we are on now. Welcome everybody. For those watching who couldn't join us today for this induction, I will be going through few things with you so you can understand the motivation for the course and few other things, including the logistics. And then we can, perhaps the ones who are alive now can ask some questions or clarifications, and then I will follow up with everyone, because the first session will start on Tuesday. The first lecture will be on Tuesday, and again, it will be held in 2 time slots. The first one at 5 p.m. UK time, and the second slot will be right around this time right now. So perfect. So if it's best for you, in accordance with your schedule, if it's best for you to join now, this is perfect for you. It's 8 p.m. UK time on Fridays and Tuesdays. Obviously today, as I said, we are not doing any lectures. It's just to go through the basics, the setup, and so on, so you can understand better the philosophy behind the course and what we expect, and also what you can gain from taking this course. Let's crack on. So the main motivation for this bootcamp is the upcoming course on topological data analysis. And this course, from a topological point of view, will require you to ideally understand these key topological concepts, these key things. If you don't, then it's basically, I won't say impossible, but it will make it very hard for you to audit the topological data analysis course. So this is the really genesis for us doing this bootcamp. And this is great because I could step in and say, okay, I will do the topology prerequisite. So that way I also get to do lectures as well. So that's it really. That's the main motivation. In terms of prerequisites for this bootcamp, obviously this bootcamp is a prerequisite for the topological data analysis, but this bootcamp also has a prerequisite. And the only prerequisite that we ask is set theory, at least. Have some basic understanding about what sets are. Naive set theory, we don't need to think about axiomatic set theory, which is a whole new beast of its own. So understand the notion of sets, subsets, complements, the operations that you can do on sets, stuff like unions, intersections, both finite and infinite collections of sets, okay? And the other thing is also, understand what indexed family of sets are. This is basically, indexing is basically labeling. We can have a set and label them with numbers, for instance. We label them with the 1, 2, 3, for instance. Just like you would do. You have a set of apples. You label them. This is apple number 1, apple number 2, and so on. But in mathematics, we can do this more abstractly. We can label things with other sets. It doesn't have to be like even countable sets, So this is the beauty of mathematics. But picking any set theory books, I'm more than happy. If you want some references on set theory, I can share some references with you. One of the best references is Halmos, Naive Set Theory, Halmos, by Paul Halmos. It's a great book. It has all the things that you need for us, including the stuff that I mentioned, but also the other things like maps, because you want to be able to go from one set to the other. In our case, we want to be able to go from one topological space to the other, just like you would do in linear algebra. You have linear maps that go from one vector space to the other, or inside the vector space itself. We want to do the same for topological spaces. And in particular, in topological spaces, we are interested in continuous maps and a special type of continuous maps that we call homeomorphisms. These are the structure preserving things that you will learn. But before that, you need to understand the basics of maps between sets, like these terms, including injective, does it mean to be injective a map? What's surjective? What's a map being bijective? If you know this, then you should be very good position in a very good position to basically take the course, this prerequisite bootcamp. We didn't want to start from set theory because otherwise this thing will drag on forever. So this is the best compromise that we could come up with. So we can, basically this is a mini marathon because the topological data analysis course, it's scheduled to be released on maybe July the 27th or 30th, something like that. Yeah, so we have 4 weeks to go over this bootcamp in order for you to have the prerequisites that you need. And then soon after we release we start with topological data analysis course. And because we are doing 2 lectures per week, I will elaborate more on this in the next segment of the presentation, so we can understand more. You can understand the logistics of it. We shouldn't have any problems with the timeline stuff. Okay, so there are 2 key outcomes for this course. I hope the slide is visible. Sorry for the font if it's small. I will also share these slides with you. Everyone who's on the thing who signed up for this course will have access to this slide. So one of the key outcomes is for you to be in a position of solid understanding of metric spaces, so that when we give you a metric space, you are able to construct the corresponding topological space. So you will learn that every metric space has an underlying topology. This is one of the things that you will learn in this bootcamp, and most importantly, you will feel comfortable with, when giving a metric space, to be able to take that metric space and then induce the underlying topology attached to that metric, and then say, hey, here's the corresponding topological space, and then all the other properties that come with it. So this is one of the key outcomes, basically. The second outcome is really to have this mental flexibility to be able to go from intuition to thinking abstractly, and also to looking at how possible applications of this the concept that you learn, to look at it from an application side, how useful, where these concepts show up from the application side. And on the other hand, also be able to do the other way around, go from intuition to abstraction and application, but also be able to go from abstraction, intuition, application. So this is one of the key outcomes that we think, if you stick with the course, you should have developed a mental framework that enables you to do this, to go from into the first circle there, from intuition, abstraction to application, thinking this way, but also the other way around, starting from abstraction, building your intuition, and then thinking from an application point of view. So these are the 2 key outcomes that we really want everyone who joins this course to have. And we have no doubts that if you stick with the program with consistency and discipline, you should have no problem in achieving this mental framework. And one of the approaches that we will take, even though from a practical point of view, the type of topological spaces that are useful mostly used in like machine learning, in physics, engineering, and so on, are topological spaces that are generated by the metric space structure. So in most courses, they would start first teaching people what metric spaces are, and then teach people what topology is, and then glue everything together to say, okay, this is how they think. But we are doing the other way around, because we think starting from an abstract point of view, so to separate the topology from the metric space structure is the best way. exactly because of the mental framework that we want you to develop. This mental framework. If we start with metric spaces, it will be very hard for you to develop this mental framework. So it's better to start with the abstract point set topology to show that topology is very general, and that there are other type of topological spaces that are very useful. We will not touch those spaces, but there are topological spaces that where you cannot define the notion of metric, so they don't have distance on them. And these topological spaces are very useful in stuff like algebraic geometry. A good example of this type of topologies is Zarinsky topology, which was a revolution for algebraic geometry back in the 50s or 40s, something like that. Yeah. So abstraction will come first, and we'll give you enough abstraction. Only 2 lectures to cover the key general abstract notions that are independent from metric spaces. So you are not mixing up what is a property given by a metric space versus a general topological property. So 2 lectures is what we expect to be the minimal for us to be able to do this. And then we will go to metric spaces, define what is a metric on a set. Metric is basically the notion of distance. Define some of the important properties of it, like what does it mean to be like define the notion of similarity between 2 metrics, for example, because you can have different distance functions defined on the same underlying set, and this you will see also yields to different might yield to different topology. So you will learn when 2 distance functions are classed to be the same. So they yield the same topology. You will learn this. And then we will go into the actual metric topology aspects of the course, where we will define other topological notions that we could define abstractly, but it's actually better to define it in the metric topology, because you can build a better intuition. Stuff like a connectedness, path connectedness, compactness. This is all much more easier. Again, referring to our mental framework in here of building intuition. So again, referring to our mental framework of being able to go from building an intuition to abstraction and finding possible useful application for these things is very important. And excuse me. And this will basically help us get there by defining certain topological notions that we could have defined abstractly, but by making them a little bit more in the context of the metric topology, you are able to build a better intuition. Yeah. Because for example, in RN, you already, if you've done calculus or real analysis, you're already working with RN, so it's much more easier to build to help you build intuition. That's one of the reasons that we are doing this. So we will have a light touch abstraction approach, but we will have abstraction, enough abstraction to give you the notion, convey the idea that topology is very general. So it has nothing to do with the metrics. You don't need the metric spaces to have a topological space, and then we build from there. And the test book references, I won't particularly be using these. This is more for like if you want to do your own self-study, which is recommended, obviously, to supplement the lectures. I recommend on the topology side, I recommend Moncrief. This is classic. You can download this if you Google or something. You will have a place where you can download this for free. Basically, you don't need to. Even the other one, I will not be able to do this, to give you a link for this for compliance reasons and other stuff, company stuff. But yeah, I have no doubts that you will be able to download this as well. So the second reference is Introduction to Metric and Topological Spaces. This is okay. Some people complain it's not the most friendliest thing. I actually think it's not bad. These are the two references that I would say for you to get in order to do your self-studies in between the sessions or after the sessions with me. They are enough in depth. In fact, they cover a lot, and we only need portions of each, basically. And I will not be following necessarily them because I've taught topology before in the past. So most of the stuff, the approach that I will be taking is slightly different based on my experience teaching students, especially those not coming from a mathematics background, where I needed to obviously also be abstract, but at the same time understanding that people are not coming from a mathematics background, to try to find that balance between being very rigorous. Obviously, we will be rigorous, but also going through like a pathline, like a pathway, where people can absorb the abstraction in doses. This is my approach. So it won't be exactly as this book, these books, dense, like definition, theorem proof type of thing. We will have that as well, but the approach will be slightly different. I won't necessarily, just to let you know, in case you want to ask which chapter I'm looking at. I will not. I will just follow my own style. In fact, a good thing for you, a motivation for you, is that I will try always when I teach. I always like to teach people the way that I hoped my professors taught me in the past, in a less painful possible way. So yeah, so I will do my best to convey the core stuff without you being lost in the unnecessary things that you don't need for the topological data analysis course. So we'll be very focused on what we need. That's the mission for this. And now some of there might be some typos, or maybe I've misspoke somewhere or something, but that's not a problem. This is just an extra thing that I thought would be nice to, especially those not coming from a mathematics background, because these terms will show up again and again. And it's also, some of them are ubiquitous. They are behind scenes. Mathematicians don't mention them, but you are expected to know they are referring to them. One of them is axiom. An axiom is just basically something that, a statement that you take for granted. You don't need a proof. These are like, if you will, the rules of the game for what you want to define. And the axioms generally come in the form of definitions. This is where the axioms will come in. For example, we'll say, let's a vector space is a set V with the following axioms. In fact, in most textbooks, they wouldn't say the following axioms. They would say the following conditions. So when you see a definition and you hear the word condition, those conditions are axioms. But generally, mathematicians don't reference the word axiom anymore. They just say, these things, this definition, this object satisfies this. And by this, the things that they list are the axioms. So just to let you know, just in case you see a definition and then you say, well, hang on a second, what is this? How did the mathematician come up with this conclusion? Show me that. Well, with axioms, they are just rules. So you take them, they are principles. The mathematician doesn't need to give you the justification for them. Obviously, before a mathematician gives you a set of axioms defining an object, they have spent a lot of time thinking about them carefully so that they don't generate contradiction, for instance, because then the axiomatic system is broken. The other thing is you cannot have a set of axioms, defining something that basically are a consequence of each one. So basically what I mean is the axioms have to be independent from each other. Otherwise, they are not axioms. Yeah. So That's just a brief thing. I always get nervous when you talk about axioms, because there's a lot of debates on the foundational side of mathematics about the different axiomatic systems and what does it mean and so on. But yeah, that's all you need to know. The axioms come in forms of definitions. And the definitions, the conditions you see there are rules. You just take them. You don't need someone to justify, why. Why is this? There is a reason. Generally, there is a reason. We will learn in the definition of topology, for instance, some of the motivations behind the current definitions that we have right now. In fact, you will learn at some point. I'm jumping the gun now. In the early days of topology, Hausdorffness used to be part of the definition of topology. And then the mathematicians took that condition of needing to be a Hausdorff. So it's called the separability condition, or separability axiom. And that opened a huge opportunity for other type of topological spaces, like the ones generated by the Zarinsky topology, for instance, that are very useful in mathematics. So that's the thing. The other thing, obviously, you are familiar with, is a theorem. Theorem is something that you can prove, a true statement. And the mathematicians use the word theorem, or in the textbooks in particular, for important results. So when you are reading these books, you often don't see very often you don't see the word theorem that much. You see something they say called proposition. For example, proposition 1.1 or this proposition, we will use that as well. So basically what that means, we will reserve the word theorem just for the important results. For the others, not necessarily trivial things, but they don't deserve to be called theorems, so we call them propositions. In fact, I've written this in the next slide, I believe. Yeah, in the next one, not this one. So the other thing is, another term that you'll come across very often is the term corollary. This is basically a consequence of a theorem. So something you prove immediately based on a theorem that you have proven. And this requires minimal effort. That's why it's called corollary, like a consequence. So it's like very easy to prove if you already proven something. So it's basically you cut off a lot of work ahead of time by proving the previous thing. This becomes like corollary. On the other hand, there is the other side of things where you want to prove something, but you need something before that, before you prove the bigger thing or the most difficult thing, which is lemma. So lemma is basically this auxiliary thing, this thing, helper, basically, that enables for you to use that to go and prove a theorem. So you will see this as well very often in textbooks and so on. I don't think we will use any of them, or we might. We'll see how it goes, but just in case you see this word, this is also a theorem, just like a corollary. They are theorems, but just, they are organized so that, in the context, it is understood in the context, where they fit in the context of mathematical proofs. One is corollary is a consequence of something else. Lemma is a build-up of something else. And as I was saying, proposition is, it's a theorem, a lightweight theorem, basically. So we don't call them theorem because they are not trivial, but they are not as important to be called theorems. And the final thing, which we definitely will not be looking at, well, maybe I might mention one thing or the other on the topology side, conjecture. These are like things, open problems, basically. Some hypotheses that mathematicians, based on observation or signals or data, they think something is true, but then no one has ever been able to produce a proof yet. A good example of this is the behavior of prime numbers. For example, the Riemann hypothesis. This is an open problem, and yeah, so it's a conjecture. This thing, so it might be true, it might be false. Until someone proves it or find a counterexample, there is, it's still a conjecture. Some mathematicians even argue it might be undecidable. So you cannot know whether it's proved, whether it's one way or the other. So that's basically just key jargons that are useful to know. So that's it in terms of this part of the presentation. So the key thing is really these two things. The outcome is, the first outcome is for you, after taking this course, if we give you a metric space, you should be able to induce its underlying topology. This should be a piece of cake. So this is outcome number one. And obviously, if once you are able to do this, then obviously you are able to understand all the other things, properties that the metric topology has, some of the stuff that we will be covering. The second thing is this mental framework, this ability of going from intuition to abstraction and thinking concretely, in terms of application, and the other way around as well, going from abstraction to intuition, to building up an intuition about the abstraction, and then looking at the concrete like application side of things. Yeah, so these are the two key outcomes that I think we feel confident that anyone who takes this bootcamp should be able to develop along the way. So I'll stop sharing this so I can go to the second part of the presentation, the other document. But I will leave it for maybe 1 minute to see if anyone, Tony, I think you just joined, or anyone else who, if you have any questions. If not, I can go to the actual structure of the program and the guidelines and rules and this stuff. Any questions? It's well understood, everything? Perfect. Okay, so I'll stop sharing this and I'll pull the other one. And the welcome pack, I think it's only if you already accepted the, because this is a live bootcamp. We are not doing it through the learning management system, which is more for self-paced, pre-recorded stuff. For live stuff, we in the case of this being a bootcamp, we are using Google Classroom. Okay, so let me share the screen. Again, I will share this. If you haven't got the slides, will be posted on the thing to you later. These slides, these particular slides, the lecture slides, there is a caveat that comes with it. So just bear with me. Okay, so the prerequisite stuff I already covered. I will jump straight into this section. Let me just zoom it. Is it better this way if I zoom it like this? Oops. Is it okay? Is it big enough? Yeah, so let's just focus in item number 2, which is the schedule. When you first signed up for the course, maybe those who join now, sorry, you probably were not given to this because we already decided we had to look up the schedule. But in the early days, those who sign up, as they were signing up, we will give them a survey to decide, because we will have 2 lectures per week. So this will be 2 lectures per week. And each lecture will have two time slots. This is the reason for this is because, this gives us the possibility to fulfill people who are based in Europe and Asia, but also people who are based in the Americas. So that way, and people who are based in Europe as well, if they miss their time slot, they can go to the other time slot. There's no problem with that. At least you have two time slot to give you a chance to attend the live session, because these lectures, the live lectures, will not be recorded. This is exactly one of the reasons that we are doing this, is for you to show up, because this is meant to be interactive. So it's not like a self-auditing, just passively watching videos. You need to show up, otherwise you will miss the lectures. And I will come back to that. In the only equation where we might record is possibly if I have an internet problem with the internet, for instance, because I'm in the country in countryside in France. Sometimes I'm using mobile. Sometimes the internet goes a little bit, but it's very rare for that to happen. So if that happens, then I might consider just recording and uploading, and then we can reschedule for another day just for live session to clarify what you have seen on the recording. But in principle, the lectures will not be recorded because this is meant to be a live bootcamp for people to show up. So they will be held on Fridays. Obviously, today is not a lecture; it's induction day, so we will not have any session on. There's no lecture today because it's induction, but the first lecture will be on Tuesday, actually. So next lecture will be on Tuesday at 5 p.m. The first slot, and then the second slot at 8 p.m. This is British summertime, BST time. It's the same lecture, but it's going to be repeated in 2 time slots. So if you miss one, you can go and jump into the other. And then lecture 2 will happen on Fridays at the same time as well, the same time slots. And the tutorials, the way we decided with the people from the previous session, because they were the majority, the bulk of the class, we will have like a weekly gap between the lectures and the tutorials. So say you start on, say for example, you do, obviously we are starting on Tuesday, which is great. So we do the Tuesday, the first lecture, on Friday, the second lecture, then the tutorial session will not be on Saturday, the next day. It will be the week after. So this will give you 1 week to obviously digest the stuff that has been covered, and then we go over the tutorials. And in respect to the tutorials, active participation is really required. This is one of the things that we want people to join this bootcamp. If it's passive stuff, then just take there is a course on topology, crash course on topology on the LMS on our platform, where you can take it on your own pace. But the live sessions are meant to be participatory. So you need to come up with try to solve the problem, share with us. Don't be shy. That's one of the reasons that we will not record them, so you don't feel shy to that someone is recording you that we'll put on YouTube or something. So participation is really required, recommended, in fact. Okay, and in particular for those who want to get certification from us. So you don't need to have a certification if you just want to refresh for the topological data analysis course. You don't want a certification, then okay, yeah, that's fine. The bar will be lower. You can just show up and watch or whatnot. You don't need to be, but to have a certification, we require participation. In particular, being on session, so we can assess your mathematical depth in order to be able to issue the thing. We will have a graduate student, in principle, to do the tutorial, to conduct the tutorial with you. We are thinking about the tutorials to be only for those for problems that are really hard. For the trivial problems, there is no need to waste to take your time to schedule and come back and so on. We can maybe just a recording will suffice or something. But even for the harder one, we might actually record, and then after we go through the live session where everyone presents their proofs and these things, and we give them advice or whatnot, we will release our own thing, so you can watch, compare to what you have done. But we will not release it before the live tutorials. Otherwise, it defeats the point of you, trying your best to actually do things. And we do encourage you to try your best to do, to practice. Don't feel shy. If you make a mistake, so be it. This is an opportunity to make a mistake and then learn how to address the mistakes, whether in doing proofs or some other things. So participation is definitely encouraged, and it is a must if you want at the end of the bootcamp to get a certificate that you can go and wave on LinkedIn or something. So the certification will definitely. For those who want to certification, they have to submit. So there are conditions that comes with it, participation. And the other thing, they have to submit the assignment before the live tutorials, because otherwise it doesn't make sense, right? They see someone else doing the thing and submit after. Late submissions will not be accepted. So This is the condition for certification. If you don't want certification, then you don't need to submit assignments, because you are just auditing for refreshing for the topological data analysis course. So you don't need to get anything. Sorry, I was just trying to plug my laptop. Yeah, it's done now. So that's the condition for being for having this certification. Is you need to be to participate in the live tutorials, be on screen, and go over your proofs. It doesn't have to be whiteboard. You can write your proofs in a thing, as long as you can walk people over your proofs. That's fine. And the other thing is, in terms of submissions, we will not accept handwriting submissions anymore, because it's just too much hassle to try to decode people's handwriting. My handwriting is terrible already, but imagine you have like 10, 20 people with different type of handwriting, and it's just too much time consuming. Plus, having a LaTeX skill is an important thing in mathematics. It's not hard to learn how to use LaTeX, and so everything should be has to be LaTeX. And the things compiled into a PDF, just to make sure that things are like consistent. We have like a consistency thing across the submissions. We are not like second guessing. Oh, do they mean this? Do they mean that? Because the handwriting is is not legible. The other thing is the use of AI. This is in particular something that we experiment in recent courses, where people submissions, you can clearly, one can easily see that they are using AI. This is not the point. What we recommend the use of AI in terms of like learning, like clarification to help you study, for example, clarify some abstract concept. In fact, we have an AI tool we put up together called the Abstract Mathematics GPT. This thing here, let's see. I'll share the link for you. If you go to our website, QF Academy, you can, on the menu, you will see it. It's called Abstract Maths GPT, or GPT, something like that. And it gives you, an opportunity to use it to ask questions. Maybe you don't understand a definition or something. It's very obscure in the lecture. You want something more like using more like a natural human language thing. Then yeah, do it. By no means, it's great for you to help decode the abstract concept, but to use it in order to try to construct proofs, no, that's the red. We will not, because the purpose of this course is for you to be the mathematician, not the AI to be the mathematician. That's the thing. Now, some people, you might argue like, okay, but mathematicians are talking about proof assistance and this thing. But remember, mathematicians are already mathematicians. They are professionals. They're already thinking like mathematicians. And we want you to think like a mathematician in order to succeed in what you want to do. So part of that is you being able to complete the things, without using the AI to do it for you. Okay, it's like similar thing with coding. If you want to be a good programmer, you cannot start with vibe. Vibe coding will not teach you, the thing. It's actually better if you are already a programmer and use vibe coding to then help you build something better, to help you become maybe more productive, do like quick prototyping and these things. But just outsourcing the thing, in particular in mathematics, outsourcing the proof stuff without understanding, because if you are struggling with constructing proofs or doing the home assignment, it means there is a gap, there's a knowledge gap in you. And using this AI tool to solve it will not help you, because you will still have the knowledge gap. So it means that you don't know, you are not able to solve the problem. And so you don't know, you lack the thing, you have a gap in your knowledge. And this is not something that AI can help you feel. So we will not accept it. And when we see, especially for those who want certification, when we see a usage of this, I mean, we had an example where the person was upfront saying, okay, I'm using this, we're using this. Yeah, but even if they were not upfront, we would, it's not hard to see, especially in maths. Yeah, and then we will ask them to come and do a proof session with us to prove us. Yeah, and then we'll see without the use of AI. Whiteboarding. Yeah. So anyway, so that's the thing. AI is encouraged to help you learn, but not to help you complete assignments. That's the thing, the rule we set up for this bootcamp and in all of our courses. And the other rule about slides. Initially, I wasn't actually intending to share the lecture slides anyway, just to encourage people to write, because by writing, you are actually reinforcing your knowledge, in your own with your own notes, as opposed to just, looking at the slides, And from my experience, I've been doing boot camps since COVID 2020, when we started the quantum formalism community. Anytime, most people that we give the slides to, they end up not showing up in the live lectures because they think, oh, I have the slides. And then when they show up in the lectures, we start to see there's a gap. Why? Because they miss some of the key things that the instructors were saying that are not on the slides. Because obviously we cannot put everything on the slides. And they think, oh yeah, I can just read the slides or annotate or something, and I will be fine. And the people who were taking this approach were the ones who didn't succeed. They didn't pass because they missed the opportunity to ask questions, to clarify, or to listen. Even in the case of the lectures being recorded, they were not watching the recording either because, oh, it's 1 hour, I cannot watch the entire thing. So they just skim through the slides, slide 1, slide 2, slide 20. They do it in 5 minutes. Okay, lecture done. But it's not, because they miss huge chunk of information that were not contained on the slide, but were contained in the instructor's head, and were put in terms of the conversation as the lecture went on. So we will not share. We will only share the slides with those who attend the lectures. That's the rules. So I softened it. Initially, it was not sharing the slides with anyone, but now I decided I will share the slides with those who attend. And by attending, I mean staying until the end, not showing up for 2 minutes and then go. So there is no hack. You have to stay. You have to stay the entire place. In fact, there is a tool that I have to be monitoring. You have to stay until the end. And also, you need to be interactive as well. It's not then just log into another machine and put it out there and go. I'll be asking people just to conduct the thing, just to make sure we are doing this, not because we want to be give you a hassle. It's just because we want you to learn. That's one of the reasons we do this. We want to see impact, people learning. We're not interested. People are paying. That's okay, but. This stuff doesn't make us money. We have other things that we make money with. It's not this. We are doing this just for like impact. And for us, we need to see that people are actually serious about going over the materials. Otherwise, we are not incentivized to do this. We will just say, okay, yeah, go to Coursera or some other generic, learning things that actually they don't provide the type of courses that we provide. That's the other thing. But the other thing is we care about impact. We care about you learning because we want you to succeed. That's one of the things. That's how we can measure impact, by you succeeding, by you gaining knowledge that you can use to make a difference in your career. And your success then will translate into impact that, gives us this say, wow, okay, yeah, we were very, what we have been doing has been, very impactful to someone else, to do something. So that's why we are doing this. We are not doing it just to play like a tough bad boy type of thing. We are doing this because we want you to learn. That's the thing. And if you follow the protocols, you follow the guidelines, and you are consistent. This is a marathon. In this case, in this bootcamp, this is a mini marathon. If you are consistent, you put on the work, in 4 to 6 weeks from Tuesday, you should be able to get to the key objectives that, I was just sharing with you, in the other slides. Sorry, I forgot it's on the other one. Yeah, so that's it. I'll stop sharing now and maybe stop recording. So the people online right now with me can feel comfortable to ask any questions, and we can perhaps be more interactive. For those who are on YouTube, sorry, you didn't show up, so we will not. we will not record the questions that other people are asking, because they made the effort to be here. So sorry for that, but yeah, I'll stop recording.